All right, so when f of g of x is the same as g of f of x, and that's equal to x itself, then we say that one function is the inverse of the other, is the inverse of the other. Okay. Specifically, we can write this, that we can say that g of x is f inverse of x. So this odd notation, it looks like we're raising f to a negative 1 power. Now, that does not make it a reciprocal. Right? When you put this negative 1 right by a function name, that's a signal that it means an inverse function. So we would read this as f inverse. F inverse. Now, similarly, you could switch that around and say that f of x is the same as g inverse. So that's the notation for inverse. You have inverse keys on your calculator. Usually, on a calculator, your upper left-hand button reads second or INV for inverse. Usually, that's the button you hit that changes a button on your keyboard to an inverse. For example, right above the sign key is sign to the negative 1, inverse sign. Right above the E to the X button is ln X, or I might have that reverse. Maybe you have an ln button or ln X button, above it is E to the X. And those are inverse functions. And so typically that's what you get on a scientific calculator, is that's where they show up. And so those are inverse processes. And what does it do? An inverse process undoes, an inverse function undoes another function. And it sort of unravels it. And so let me give you an example of this. I'm going to show you how, and this is kind of an example that would be overkill in the real world, but I wanted to give you an idea how inverse processes can be used productively, and they are in the particularly perhaps in the high-tech world, high-tech engineering world, where you might see constantly changing conditions in something they're making, which require the machinery to react to those conditions, whether it be heat or electricity or whatever is going on inside. And the way they solve those on the fly, perhaps, is to use some sort of inverse process. So let me give you an example. Suppose we had to solve, let's see, how about this? Drawing a blank here. Hang on. How about 3x minus 4 over 5 equals to 1. All right. So I'm going to give you this simple algebra example of constructing an inverse function. All right. Now, what I want you to pay attention to, and this is one I think everybody could solve without too much trouble, but I want you to pay attention to is the steps involved here, and those steps are going to create a function for us. So I'm going to multiply both sides by 5. So we multiply by 5 now. We write that out. Multiply by 5. Okay, and I want my 5 to look more like a 5. Maybe that's a little better. Now that canceled the denominator, so I have 3x minus 4 equals to 5. Now what's our next step? Probably add 4 to both sides. Alright, so we add 4. And then our last step is to divide by 3. Divide by 3. And so that gives us an answer of x equals to 3. Now these steps, multiply by 5, add 4, divide by 3. I'm going to turn that into a function. And so bear with me on this. Let me erase this stuff.